Hi, my name is Jason Moran. I'm going to tell you about a project that I had the privilege of working on for Darling Environmental. What we did for this company, which is a silver mine in the Pacific Northwest, was to do a scanning and surveying project which accurately maps their structures, both above ground and below ground, in 3D form. Now, up until this point, this was never done for mines, and in our view, absolutely revolutionizes traditional surveying for mines. What we did, we were able to scan the above-ground structures in a traditional way, but we overlaid onto that a very detailed map through 3D rendering of their underground mines and their drifts and their shaft. As you go through this, it looks somewhat like a roller coaster ride, but in fact what it is an actual map of the contours of the drifts and the portals. This long shaft that you see coming down as you're coming around a bend, that's a shaft that goes 1 mile straight vertical drop into the ground. Now this is important. You can understand from a mining engineering standpoint. You want to know a number of things from this data. You want to know if, for example, if you're expanding a certain drift on a level, whether or not that's going to line up with your drilling on the other side. Or secondly, if you want to monitor subsidence or erosion in a certain area, you have a physical framework with which you can actually judge changes over time. And you can see here in the video, we're actually coming in to one particular level and we're going straight down into the shaft. This shaft, as we're looking down now, is as if you are going down 5,280 feet, as if you were falling. That is essentially what we did when we did this, is we were able to see whether or not there was any vertical change or skewing in the actual mine shaft, and that obviously bears relevance for the structural integrity of the mine. And as you go through this, you see things look kind of pixelated in the sense that there's little dots. What those dots represent, because we were able to link those into a control survey above ground, we can actually get exact coordinates of any one of those points, an XYZ coordinate, and know an exact location of anything underground. So you can imagine from the perspective of mine management, we now can depict visually what the asset looks like as opposed to a 2D drawing, which for some people they may not be inclined to actually have the understanding to know what their assets look like underground. This brings it in real time for them. And that really helps decision makers understand from, for example, a safety perspective. Where are their people? Where are they going to be expanding certain areas? And clearly there are also benefits for the above ground where we can actually use this data to do volumetric studies, for example, of tailings ponds, for example. We can also do accurate as-built of underground piping structures. And as you go through here and you go through the fly view of this mine underground, you see there are various ductworks, pipe works, ventilation works. You want to know where those assets are. You want to know their condition, and you want an exact location of it, because if a certain area needs to be fixed, if a certain area is undergoing renovations, you want to know exactly where that is. And likewise, if there's an issue underground, it allows first responders to know exactly where they're going to be going, and they can all be on the same sheet of music. And then finally, from an engineering standpoint, clearly there are benefits when you are expanding mines. If you're familiar with the mining sector, a lot of mines in these regions are located in the relatively same proximity, and some of the drifts between the mines actually connect. Well, as those mines expand, they're going to want to know whether or not they are going to be lining up with someone else's tunnel that's coming into them. Well, this can show you with zero ambiguity whatsoever of whether or not that's going to be possible or not. Here's another example of a building information modeling project that we had for a copper mine. As you can see, as you go through this mill for the copper mine, the absolute degree of precision and the amount of essentially spaghetti pipework that exists in this mill is incredibly complex. And as you can imagine, if you're familiar with mills, there's a tremendous amount of vibration, and it's a high humid atmosphere, and a lot of these structures in here often degrade over time. And many times you need to replace certain key pieces. And to do that, you'd have to have an engineer come out, figure out where the piece is and what the piece is and measure it, and then they'd have to go and retrofit it off-site. By actually having a digital representation of this, we can go virtually to the site from a computer, from a remote location, and highlight the key position that needs to be fixed, or the piece of equipment or the piece of pipe work or duct work that needs to be retrofitted, and we would have exact measurements for it. So I think what you can see from all of this data and this presentation of this mine is a number of things. What we do at Darling represents a much higher order degree of surveying than just traditional land surveying or mapping or drafting. And the data that we are able to collect has such a specific degree of granularity that its uses are almost infinite. And that's one of the things we pride ourselves on here at Darling is we're not just a glorified surveyor. We are someone that gets in with our clients who have a particular problem that needs a solution, and we work with them using a whole host of different tools and techniques and technologies to come up and digitally represent what the problem is and highlight areas to have a solution for them. Thank you very much for your time.